So dear students, in the 15th video I explain you about question number 5 of exercise 1C, wherein I have explained you how to solve question number sub number 1. Okay, so we have seen how we have found the prime factorization, and we have verified, okay, that LCM into HCF is equal to product of the two numbers. Okay, so we'll continue the same question. This time I'm going to show you from this question number 5 of exercise 1C. There are 3 questions. So number 1 I've already solved, sub number 1, in the 15th video. Now in this video I'll explain you number 3. Okay, I'd like you to try number 2 by yourself, and I'm just suggesting you be extra careful a little bit while doing this 3 and 15. Okay, prime factorization. Clear? So you try this number 2 by yourself, and let me show you number 3. Okay, so here I do number 3, 5 sub number 3. Here also we'll do same. We'll find the prime factorization, and then we'll find the HCF and LCM of the 77 and 979, and then we'll verify the relationship between HCF and LCM. So first of all, we'll start with prime factorization of 77 and 979. So for prime factorization, we'll do same step. First we'll do prime factorization of 77. So for finding prime factorization of 77, so here we need the prime numbers. So we should divide by the prime numbers. So the first prime number is 2. That means let us try to divide 77 by 2. But before we divide, let us do the test. Because of this unit digit 7, this is an odd number. Odd number we cannot divide by the prime number 2. That means 2 cannot divide 77. So 2 gone. Now next prime number we should try is by 3. We should try to divide by 3. But for 3, let us do the test again. 7 plus 7, 14. Because for 3 you have to add. 7 plus 7, 14. The sum is 14. Now recall, does 14 comes in the table of 3, or is 14 a multiple of 3? Let's recall the table of 3. 3 4s are 12, 3 5s are 15. That means 14 does not come in the table of 3, or 14 is not a multiple of 3. That's why by 3 also we can divide 77, because the total is 14 and 14 is not a multiple of 3. So 3 also gone. Okay, means you cannot divide. Now for 5, you know the rule. The unit digit of any given number, positive number, should be either 0 or 5 to be able to be divided by 5. But for prime number 5, the unit digit should be 0 or 5, but here it's neither 0 nor 5. Therefore 77 we cannot divide by the next prime number 5 also. Then comes 77. Sorry, the next comes 7. So now we should try to divide this 77 by 7. For 7 there's no test, but then if you divide by 7 also, say 7 on the 7, 7 on the 7. So yes, this 77 we can divide by 7. 7 11 is 77. Yes, we can divide by 7. Okay, look, 7 ones are 7, 7 1 0, minus 7, 7 ones are 7, means 7 into 11, 77, means 7 11 times 77. So yes, we have divided by 7. Now we got 11, and you know that 11 is itself a prime number. See, 11 is a prime number, and since 11 is a prime number, we will not waste any time. We'll divide this prime number 11 by itself. So 11 1 times 11. Okay, so we got the prime factorization of 77, which is equal to 7 into 11. Okay, now let us do for 979. Okay, here we stop here because we got 1. So now let's do for 979. Same thing we'll do. Can we divide this number by 2? Then the answer is no, because the unit digit here, say unit times 100, the unit digit is 9 here, and you know that 1 3 5 7 9 are all odd number if the unit digits are those, right? Any of those, 1 3 5 7 9. So odd number we cannot divide by 2. Since you cannot divide by 2, now let's try by 3. For 3, remember same rule, you add this and the sum should be a multiple of 3. So let us add all this to find for 3. Okay, to try to divide by 3, we'll not divide directly, we'll do the test. So let's find some. 9 plus 7 16, 16 plus 9, 25. Now, do you think 25 comes in the table of 3, or 25 is 25 multiple of 3? Answer is no, because if you keep on saying table of 3, 3 here, see the total is 25. 25, and the total here is 25, and it's in the table of 3. 3 8 is 24, and 3 9s are 27. See, 25 doesn't come in the table of 3. That means 25 is number of 3, so means we cannot divide by prime number 3. Then okay, we'll try by 5, but for 5 the unit digit should be, the unit place digit should be 0 or 5, but since 9 is 0 or 5, so we cannot divide by 5. Now comes 7. To try by 7, you have to divide in the rough. Let's divide 979 by 7. Let's divide 979 by the prime number 7. Okay, whether 7 is a prime factor or not. So look, 7 ones are 7, then 7 4 1 breaks, so 7 threes are 21, then 7 nines are 63. So clearly you can see that 979 is not divisible by 7, because here remainder is not 0. Okay, so that means 7 is not a prime factor of 979. So let us divide this 979 by next prime number. By 7 we are not able to divide. Now let's try by 11. Okay, because next prime number is 11. So 11, so 11 is table, you know. So 11 8s are 88, because 11 is 9 and big. So 17 minus 8, 9, and this 9's done. And then 11 9s are 99. So remainder comes in. That means what? 979 can be divided by 11 completely. So that means 11 is a prime factor. 11 is a factor. So that means now we'll divide by 11. See, 11 8s are 88, which we have done here. 11 8s are 88 and 11 9s are 99. Means directly 89 you can write. Directly 89 you can write. Or even if you do also 11 is 88, 9 7 is 89, 9 9 18, 11 9s are 99. So here we got 89. Is that a big number? You may be thinking like, by which table will divide? No, because see, again you may try by 11, you may try, no, again it may happen that you may try by 11, you may try by 13, but see, you'll waste time, because you know that 89 is a prime number. See, we got 89 here, and if you have this prime number by heart, that's why I'm insisting that try to by heart all these prime numbers up to between 1 to 100. Okay, that means up to 97. So we can see that 89 is clearly a prime number. So that's why we'll not waste time. No need to think by which table we can divide. Okay, by which factor we can divide. Okay, this one, since 89 is a prime number, so 89 179, any prime number comes, you divide by itself. Okay, no need to waste time, because okay, so means we have done the prime factorization of 979. Okay, so now we'll write prime factorization of 77. So the prime factorization of 77, we got what? 7 into 11, and since 7 is only 1 time 11 times, so we can give power 1 directly here. Okay, and now we'll write prime factorization of 979, and this we got what? See here, 11 into 89. So this prime factor will write in power notation. So 11 also 1 time, and 89 also 1 time, so write power 1 1. Okay, so we got a prime factorization. Now we'll find the HCF and LCM. First we'll find HCF. Therefore HCF of 77 and 979 means HCF of these two given numbers. So HCF means what? HCF means the product of all the common prime factor with the lowest power. Okay, so see the common factor here, common factor. See common prime factor. The common prime factors here are only 11. See, 11 is the only common prime factor. So right, 11 with the smaller powers. Suppose you have 11 power 2 and 11 power 1. So 11 power is smaller. But here in this particular question, powers are same, 1 1. So that's why 1 is small already. Okay, we don't have smaller than 1. Okay, so same, we will take power 1. So okay, so and see, besides 11 there's no other common factor. 7 is here, 8 9 is here, but these are different, okay, from each other. Okay, so 11 is the only common prime factor, so we got the answer. So 11 power 1 means 11 one times means 11. That means the HCF of this number, the highest common factor of this two given percentage is 11. Okay, so HCF finished. Now we'll find LCM of 77 and 979. Now remember LCM definition. LCM means the product of all the prime factor with the highest power. So here all the prime numbers whatever are there, you write. The 7 is a prime number, 11 is a prime number. Common ones write once only, no need to repeat. Like 7 is there, prime number, 11 is there, prime factor, and 89. Product of all the prime factor with the highest power. See here, 7 has power 1. 11 though coming 2 times, write only 1 time. And highest power. Here highest power is 1 only. And 89 also 1. So all 1 power. Okay. So write all the prime factor with the highest power. Okay. Prime factors we don't repeat. Write once, but the highest power. So now you know 7 power 1 means 7 only, 7 one time, 11 power 1 means 11 only, means power 1 no need to show. In simple word, power 1 no need to show. We understand it's power 1 here, power 1 no need to show. Okay, and now we'll multiply the 7 into 11, 77, and 17 into 89, 77 into 89. So 9 7 63, 8 7 56, 56 plus 6 62. So 7 9 63, and then same 6853, 6853. So the LCM is what? 6853. Okay, so we have finished finding the HCF and LCM of these two given positive integers. So first part of the question is finished, but we have to do second part. This is verification. For this question 5 we have to verify also. So let's do the verification. So now we'll do verification. And remember how we have done verification. What we have to verify in this particular question? We have to verify what? Verify that LCM into HCF means the product of LCM and HCF of these two given numbers is equal to the product of the two numbers. Okay, product of the given numbers. Okay, so to verify this, so copy this again. So verify what? LCM into HCF should be equal to what? It should be equal to the product of the two numbers. Okay, so LCM into HCF we have to verify that it's equal to the product of the two numbers. So now we'll put the values. Okay, so this means LCM is 6853 into HCF we got 11. So LCM we got, HCF we got, so put the value. Okay, whatever answer you got. And product of two numbers means what? Product of these two given numbers. This is 77 into 979. So what to do is that now just multiply these two and these two in the rough, and you write the values here. And those two values should match. It should come equal. If your whole process is correct, the whole sum is correct, you have solved the sum correctly, then the answer should be equal. The product should be equal. So let's multiply now. So students, you can see that I've multiplied 6853 into 11. Means I've multiplied the HCF and LCM and HCF. The product is coming 75,383. 383. Okay, 75,383. Okay, and here I'm multiplying the two given numbers. Here I'm finding the product of two given numbers, and see the product is also coming 75,383. Okay, so hence we found that the product of HCF and LCM of these two given numbers in question number 5, sum number 3, the product of HCF and LCM of these two numbers is 75,383, and the product of the two given numbers, that is these two given numbers of this question, is also 75,383. So since they are same, so therefore you conclude by saying therefore left hand side is equal to right hand side. Left hand side means the product of HCM and LCM, and right hand side means the product of two numbers, and yes, they are equal. So we'll conclude by writing hence verified. Okay, So this sum has also been done for you. Okay, so practice the sum nicely. Okay, and try number 2 by yourself, and try number 2 by yourself. Okay, clear? Yes, 21 different. Try by yourself. Thank you.